Welcome to our next video. This one is on MPLab again for tutorial 1 on the template. And I'm going to expand and go a little bit more in depth about what these files are and what they do and how we want to structure our code, because that's a really important part of what we're going to do in the next 3 or 4 weeks in this course. Just a review of the items here. We have the project window, we know, and we have this dashboard, and we've got our source code window, and then we've got the output window. So this MPLab X IDE stands for Integrated Development Environment. It's a good thing to write down. And again, it's a fancy way of saying there are these multiple functions in Windows. So places to write code, places to make new projects, etc., that can be used and organized in a virtual environment. But the compiler, which is the XC16 compiler, is working behind the scenes as we build our code. So again, if I go up to my clean build, I will get a clean success, hopefully build successful here. There we go. And again, if you look over here to this dashboard, you can see the flash that's used is only 3%, and we haven't used any RAM because we have no variables. So it gives you some information about the memory. And again, that memory is divided up into the program memory, which is what's being flashed to the PIC eventually, and then the data memory, which is what our RAM is, which is essentially variables. And we have our PIC up here, and there's some other information we probably won't really use. Okay, I don't have a PIC-Kit3 plugged in, so it's probably not happy with that. I don't know what that I is for. All right, so if I go back to my file structure that I showed you earlier, you can see that all of these files need to be in this folder, which is my .x folder. So I have my config bits, I've got my delay, I've got my main.c, and then I've got my GLD in my header file. So they all need to be part and parcel of that directory. Okay, so you need to copy and paste those for every single project that you do and put them in all of your directories, okay, to ensure that you get success in coding. So back to MPLab X, let's look at the top here. Just a comment about programming conventions. Communicating your code is almost as important as the code itself. So code that's not properly communicated is more difficult to debug. And this template provides an example of how each program should be structured. So all of your programs should be broken up into these individual subsections that you see here, which I have used this star. So you can see these different sections as I scroll down. Each of your programs should begin with the name of the file at the top. So this one is the main.c. Okay, and I've just added some extra information here. And you want to add obviously the main. Okay, this is the module you're using. Which is the main, and that gets put there. Each of your programs should have your name and your date. Okay, and then what's really important is information about what the program does, with a title and a description about what it does. So what's it designed to do? And you always want to have that in your program. Towards the bottom here, you'll see that hardware notes are broken up into the PIC that you're using, and in this case it's the PIC 2432KA302, the FV, and it's operating at 8 megahertz. And then further we break it up into inputs and outputs. So the output ports, you want to highlight what hardware have you attached. Have you attached LEDs? Have you attached a motor? And what ports are you connecting them to? So for example, I've got here RB6 is connected to a green LED. Inputs as well, I don't have that connected, but again, it would be the same thing. I just type in here, okay, I could put inputs and then add something in there like RA is 0, maybe is a button input used for turning on a green LED, something like that. And again, you would format it so that it looks nice and lines up with everything that you have there, okay, etc. So I won't get more into that, so you can see what I mean by that. Okay? All right, on to the next part. Observe the use of the /* and the */, okay, and you'll see that here. This is what I mean by the /*. So /* followed by the */ down here. I realize there's other stars here, but that is called a block comment. So anything that's in between that slash star and the star slash is going to be considered a comment and ignored by the compiler. Now there's another way you can do that, and that's to include the double slash. Okay, so anything in front of that double slash will be ignored and considered a comment as well, and you can see how it's grayed out. Okay. All right. Okay, moving on to the next section below that, the include files, which you see here. The pound include, or the hashtag include, is a directive, okay, and includes the header file, the delay file, and the config bits file, which provide access to the registers as C variables. So I don't have the delay file in here, so I'm going to show you how to add that. You just have to do your pound, okay, and you can see as I do an include, it comes up there, and then I just have to add one set of of quotation marks, and it will give me an option, and I want to add the delay. So it's quite nice that way. Hit enter, and it comes up. Okay, so if we look at these files individually, you can see I've got them open here. You just have to double click them. The config bits is a statement or a group of statements here that really enables or disables specific features of the PIC. So one thing we want is a clock, and we're going to use the internal clock that's provided in the PIC. So this is the set of configuration bits that we need to set for the PIC. And each of these parts here really describes a register, and all we're doing is we're setting that register to ones and zeros, which enables that 8 megahertz fast resistor, capacitor, oscillator. That's what that means. And there's some other ones here. We disabled the watchdog timer. We're using these PGED1 and PGEC pins for programming and debugging, okay, which is part of the PIC Kit 3. And we're disabling the deep sleep watchdog timer. So that's all information there. Now, why would I put this in a header file? Well, that's a good question. I put it here so that I don't have to have it crowding out my main program right here. I could put it here, but why bother? Why do I want to always have that messy code that I really don't need to see every time I'm starting to code my own programs? So what we do is we package it in a header file. And then that header file I put under header files here, but then I have to add this include directive so that when my code in my main compiles, it knows that this config bits.h and the delay.h and this PIC header file are all part of that. Okay, so it's a really nice, neat way to consolidate your code, and you can make your own header files if you like. If I go over to delay, again, this is just a function that I've written so that we can use milliseconds and using a function called delay, so we can have some timing capability with our programs. All right. And just if you're curious, you can see I've combined this timer 2 and 3 to be able to create a 32-bit timer to be able to do that. So you can look at this code. If you want an explanation about how it works, I'd be more than happy to sit down with you and explain it to you. And then this other one, as I said, which is the TEJ4M, provides access to registers as variables. So you can see that there are different variables, and it's just assigning those variables a specific address in memory in the PIC. So going back to main, I'm going to scroll down to symbolic constants. These are values assigned to a label that never change, and we'll use these a little later. We have local function prototypes. You place the header for all functions here, and this generates a list of function prototypes. The entire function will be placed after the main function, which is at the bottom of your source code. So if I scroll down here, you can see it says list of functions here. So the entire function goes below main, but the header, which is just the title or the first line of that function, will go up here. So if you have a lot of functions, which you will eventually have, you're going to have a whole list of them here. The global variable declarations, okay, are essential to coding. It really means that you're assigning a name or a label to a specific address in memory. And as we know, variables allow us to store different information in the same location, which is why they are called variables. These global variables are very useful because they can be seen by all parts of our program. And then finally, this main function here, you can see, this is where we put the body of our code. The main function is followed by a pair of braces, and it's within these two braces that make up the main body of the program. Notice the spacing of the braces. The open brace, this one right here, is margined identically to the closing brace down here. So it's essential that you structure all your code this way because you'll have multiple braces to keep track of, and you need to ensure that one lines up with the other so you don't get confused. The while statement here, while 1, so as long as this conditional expression is true, which it will always be true here because 1 will always be true, then it will just continue to loop over and over again. Well, the reason why we do that is because all embedded systems are designed to wait for an input. So if you think about that like a fire alarm or a microwave oven, but it's essential that those picks have something to do. Otherwise, they start looking for something to do. So this creates that endless loop. And also notice that the closing brace has a programmer's comment too, and I've actually named it main template, so I'll just change that to main and save my work. And then the functions, this is where all of our functions will go below main. And again, I think you're going to be finding you're going to write a lot of your own functions. That concludes this video.